Hello, this is Phil Thomas. Today I'm going to test a 2-watt Viasat KU-Band BUC. Now here are the components. I'm going to generate the signal using the Comtech EF Data CDM570L modem. I'll connect this power head to an Agilent power meter. The BUC has an N-type connector, and through that N-type I have to give it a 10 MHz reference and a 24 volt DC, both of which will be provided by this Comtech CDM570L. I'll be back in a couple of minutes when I complete the setup. Everything is set up to begin the test. The BUC is connected to the crossguide coupler and the dummy load. The output, the TX port from the modem, is connected directly to the N-type connector on the block-up converter. And now I have to make a few adjustments on the modem to make sure we have a 24 volt power supply being transmitted and also the 10 MHz reference. This is the starting menu on the CDM570L. First thing I need to do is to go into Configuration, ODU, check the BUC, DC power, and it's off, so I'm going to turn it on. 10 MHz reference is on. So we're ready to begin the test. I'm going to set the modem power low to begin with. Minus 40 dB is as low as it will go. So that's a good place to start. I'm going to check the frequency. 1210. I need to change the local oscillator frequency on this modem so that it will accurately reflect the KU-band output. The LO frequency is set in the same place that I just set the 24 volt. There are several different local oscillator frequencies that this could be set to. There's no indication on the BUC itself. I'm going to assume it's one of the common ones, and I'm going to go for 1305. I can confirm that this is correct because I have an IF frequency of 1210 and it's translating to an RF frequency of 14215. This BUC has a range of 14 to 14.5, so this is right in the middle of the range, and so I'm going to guess that I've set my local oscillator frequency correctly. Now let's go and look at the power meter. So now everything is set up. I'm going to apply some power to this and see where the maximum usable power is on this BUC. Supposedly a 2-watt BUC. First, check the power setting. Minus 40, that's the minimum. I'm going to go back to on-off, turn it on, and check the power meter. Power meter is still showing in the milliwatt range, so I'm going to increase. By increasing, it means that this number is actually going to decrease because this is an attenuation. So we've taken it down a couple of notches and we're still in the milliwatt range. Okay, down to negative 30 dB. Okay, now we're starting to see 2.5 watts. I took that down quite drastically. I'm going to go back up again. Well, by up I mean I'm going to decrease the power to negative 25. Okay, so that's not quite 1 watt. So we're obviously in the right level now. So I'm going to go down to 23. And we're looking at 800 milliwatts. Now we're at 1.65 watts. .02 watts. So I'm going up in half a dB at a time now. 2.25. .34, still going up. 2.4 watts. .42. We're about here now. We're not getting any more power out of this. And again, this is about right for a 2-watt buck, just over 2 watts. And so when it is measured, or when it's certified by the factory, they call it a typical. So it's a typical 2-watt buck. If this amplifier had been sold, I would have completed a much wider range of tests. I only did this at a single output frequency. The total frequency range of this buck is 14.0 to 14.5 gigahertz. The power output does vary with the different frequencies. And so when this buck is finally sold, we will do an exit test and we will test the full range of frequencies to ensure that the power is consistent throughout the buck's range. That's all for today. So I'm going to turn everything off and wrap it up.